show of hands. Did anyone here go to Software Circus in Amsterdam? No, I love that because I've blatantly stolen all the slides from Luke's talk, and anybody who went might get a bit bored. So great. I'm going to talk about stateful containers. Everybody knows what containers are. Like, let's just get a general sense. Everyone here is comfortable with Docker and what containers are. We don't need to do the basic thing. Let's just. I like doing this game. It's great. Right, we're good with containers. So stateless containers, 12-factor apps. Everybody loves those. You know. Heroku introduced this 12-factor app way of doing things, and ever since everybody's been throwing their stateless things and scaling them, throwing them around the cluster, and that's great because schedulers can do their jobs well and scale these containers across lots of machines. The idea of running a database in containers, I often get people looking at me sideways, like I've just insulted their sister or something. Like, how dare you do that? That's a crazy thing to do. What we're trying to do is say, why not? And busy building tools to help people do that, because you can't just start a database in a container and find the container stopped and all your data's gone. That's obviously not a very good thing. So the general theme of this talk is going to be, it's quite a short talk, so I'm not going to cover all of the angles. We're just going to go through the basic idea of running stateful containers, what sort of things you need to think about, and I'm going to introduce Flocka. So Matt mentioned that we make Flocka, that's our main open source product. And I'm going to give you some use cases, so this is why you might want to care, hence the talk title. And then a quick demo, so if the demo gods are smiling, it will be great. If they're not, I'll just wave my hands and tell you what would have happened instead. So what we have here is like the monolithic app with a single database. I think everybody who's done any development has probably seen this kind of situation. You have various parts of your app and there's one database and everything speaks to the one database, and maybe there's a couple of processes. If it's really a monolithic app, there's one process and one database process and the web browser on top, the classic three-tiered approach, right? What's happening now is microservices. And so I don't know if anyone's heard of the drinking game, where if in a talk you hear the word microservices, you have to drink. I'll happily pick you up the floor after this talk, so forgive me for saying the word too many times. Anyway, what are microservices? It's this idea of decoupling your application. So it's not one massive thing. It's like a juggernaut. You have to move around the cluster. You can only do one thing to everything. It's not composed of lots of small parts. So microservices is a very big topic at the moment. It's like the buzzword at the top of the list of buzzwords. Adrian Cockcroft is regarded as the godfather because he looks cool, and also he kind of really pushed microservices through in his role at Netflix, and they do quite well. It's worth mentioning it's not the only way. Etsy also do quite well, and they're big advocates of the monolith, right? So it's not that you have to do microservices unless you're just trying to be cool, in which case reevaluate your decisions, but it's actually a technical decision that can really help with lots of things. For instance, what if one part of your code has a serious bug? If that brings the process that code is running in down, and you're a monolith, the whole thing goes down. So these sorts of reasons, I'm not going to deep dive into microservices, but just to give you a context, there's lots of advantages to splitting your app into lots of small parts, having them talk to each other. There's some downsides, like latency. That's a downside. So hence, it's not a one-size-fits-all approach. Right. So when you think about microservices, you might split your app into lots of small parts. So one part might be, does this user exist? Another part might be, give me the information about this product that I need to render on a page. Always, unless your data is ephemeral, it doesn't exist, you're going to need to speak to some kind of data store, right? So to very quickly go back to this picture, if in a microservices setup you have only one database, you kind of like, you're between both of the worlds because you've got lots of different services and they're speaking to only one database. Wouldn't it be much better in this world where each of these microservices have their own data store? And that's an encouraged pattern. It means that genuinely now each part of your app is composed. It's not that only the processing part is composed, but yet your data store is still a monolith. So it's a pattern of microservices to encourage each service to speak to its own data store and to bring all those services together into what you would call your entire app, right? But you don't just have one set of microservices, you have staging and dev and your production and lots of different A/B testing versions of this whole system, and before you know it, you've got this whole gamut of different services you need to manage, right? So tools like Kubernetes, a show of hands, I told you I like this game. Kubernetes, who's heard of this? Yes, these guys are really experts in Kubernetes, by the way. So if you want to learn more, then go and speak to Matt and Matt. Which way round are you? First one. Sorry. Marathon and Mesos. Marathon is a Mesos framework. Who's heard of these two things? Okay, we're well versed here. This is good. And Swarm, which is like Docker's version of we want to do clustering too. So everyone's heard of Swarm. Okay. So what these tools do is try to manage this complexity for you, right? So you're trying to define a manifest of what you want to run, and these tools will decide which servers to run all these things on. And as an ops person now, you're just saying, hey, I just want to tell you what I want, can you go and do it for me? Because let's face it, managing just like that screen there manually would be a real pain in the arse. I wouldn't want to have that job. The key though is to come back to this theme that we're talking about is stateful containers, even if that's what you're running. In the standard 12-factor app world, these things are speaking to external data sources, right? So your app is here, I love this tool, your app is here and your databases are somewhere off here. They're not managed by these schedulers. That's the sort of 12-factor way, is write stateless processes, keep your data stores external. So this is where I've got ahead of myself. This is the point I've made. Like we're smashing up this idea of having one database into lots of little parts. We've got lots of complexity to manage, right? So this 12-factor idea is a great way to do things, but it fragments your cluster now, your stack. You have this list of things that you're running that are stateless, and you're also relying on this other bunch of processes, but they're outside that manifest. The whole point of what I'm talking about today is bringing the stateful stuff into that manifest. So regardless if you're using Kubernetes, Mesosphere, Swarm, Cloud Foundry, Colin from Cloud Credo is here tonight somewhere. Where's Colin? There he is in the corner. So if you want to learn about Cloud Foundry, he's your man. All these tools are really great at scheduling stuff across servers, and why do we not run databases inside containers as well? And now we have, in one place, a consistent platform to deploy our entire stack, right? So I always say petal and cats. So I'm going to get it right. I'm going to say pets and cattle and pets. Who's heard of this? This is a very well bandied around phrase. Okay, so I don't need to explain what it is. Let's go back to this land where it was like 1990 and you had one server and you gave the server a name and it also had the database process as well as your app on the same server. It's fragile. Both things are pets. The data itself is a pet because if the data goes away, you care like a pet. You don't really care about cattle. It's always mean to the cows, but we get the idea. The servers are pets because if the server blows up, the whole thing has gone away. So it's a very fragile setup. EBS and EC2 come along and they say, hey, I think that'll do, yeah. If the server goes away, I don't care, I'm going to spin up another one and attach an EBS volume to the new node. So the volume, the data is still very much a pet. You really care about the production data, but you could literally shoot a node in the head and have the data volume be reattached to the new nodes, right? So there's this middle ground. This is where Flocka lives, right? So to make it clear, we're in the business of storage orchestration. We're saying, your data is very special, your compute isn't special, we're going to move the data around to the compute node that needs it. This next stage is things like Ceph and ClusterFS and distributed file systems, things that say Elasticsearch, and there's a whole bunch of applications as well that sit on top of these kind of distributed file systems. I can shoot literally a node in the head that has a volume attached and the data goes away because it's local storage. There's no network block device that you reattach to another node. And the application will, the file system or Elasticsearch, the application will move the data because it's got backups of that particular data around the cluster. So there's three kind of layers of cattle and pets between compute and volumes. Let's talk about Flocka and how it manages this process, right? So let's talk about PostgreSQL and MySQL and database servers that literally speak to one volume. And you say, let's run this database on this node, and the node fails. And so a scheduler might kick in and say, let's run that database onto another node. There's no tooling in that system that would say, I need the volume that had the data now attached to the second node. In a nutshell, that's what Flocka is trying to do. It's trying to orchestrate your volumes alongside the container orchestration platforms that I've mentioned. And the two work well together. That's what we're trying to do. We're trying to bring this world of, I like to do this hourglass thing, where on the top here you have all the orchestration platforms, right? You have Flocka in the middle, and on the bottom you have all of the different storage backends that Flocka supports. So I'll go through those different backends shortly, but imagine the matrix from hell if you had to try and tell the orchestration platforms about all the different storage platforms that there were. It would be a lot of code and a lot of sort of cross-wiring. It wouldn't be fun. So we are trying to make an abstraction between the choice of storage backend and that being triggered by this orchestration platform. That's fundamentally what Flocka is trying to do. So this is what would happen with native Docker, right? Is if we moved a container from one host to another host, Docker has no concept about this part here. You know, if we mount a volume in Docker that's just a host volume, everybody comfortable with the -v syntax in a Docker run command? So let's show hands. Like who understands? Yeah, okay, most people, about half. So you can run a container and you can make no comments about the volume, and the container may well be writing state to disk, and then the container stops, and basically you've lost your data. That's the basic starting point, right? Which is really bad. And so Docker introduced this volume flag, which says, hey, my container is going to write to /data inside the container, but I'm going to mount that volume onto the host using the -v flag of Docker. So now, if the container stops and starts on the same host, the data is still there, which is a kind of rudimentary way to get around this ephemeral state problem when you're running inside a container. Problem is, and as we've already mentioned, you've got lots of servers and you've got a scheduler platform that's throwing containers around all these servers. If the container starts on another server, Docker can't magically move all that data to the other server. It doesn't really understand that concept. So it's patently not enough to just use a native Docker volume to start thinking about scheduling across more than one host, right? So with Flocka, it kicks in the moment it notices the container's moved to the other host and moves the volume with the container. And a nice phrase I like to use is, Flocka treats the container and the data as a single atomic unit, right? It's not two things, it's actually one thing. And Flocka's trying to trace the container and take the volume with it. So probably hit that point to death now. We go to the next slide. Here is a basic overview of how the cluster works. There's like a control service, so you can post requests to the control service to say, I want a volume and I want it to be on this host. And each agent is running, each node, is running a Flocka agent. The agents are continuously talking to the control service, and so you kind of have a distributed sense of where volume should be. So that's sort of a very basic overview of how Flocka understands where the volume should be, as per where the container has appeared, right? There's a couple of different ways that this can happen. Manually is the first thing. So I'm working with a bunch of different orchestration platforms, and they're going to just use the REST API for Flocka, right? So they're just going to say, hey, I need a volume because I'm about to launch a container. Before I launch the container, ask the control service to create me a volume on the node where I know I'm going to launch the container. So that's like manual usage of Flocka. Why is that important? It doesn't tie you into any containerization platform, i.e. it doesn't need for you to use Docker. We're working with some guys that actually use, and they're very well known, systemd nspawn containers, not Docker containers. And there's Rocket as well. So if you've got the kind of platform that isn't Docker-centric, you can still use Flocka. Flocka and Docker aren't, although the name is perhaps not giving it this indication, they're not bound at the hip, right? I'm going to do a very quick overview of the Docker plugin, right? So back in February time, has anyone heard of PowerStrip? This is yay, nice, I like that. So basically PowerStrip was our way to say to Docker themselves, we need an ecosystem of companies building tools around Docker. To do that, we need to interface with the Docker daemon somehow. Now Docker's written in Go. You don't really want to be writing Go and recompiling the Docker binary every time. That's just not very nice, and it's not going to work. So we made this thing called PowerStrip. It's basically a man-in-the-middle hack that sits in front of the Docker daemon, right? So when you go Docker run, it makes a HTTP request to the Docker server. In the PowerStrip land, it would actually capture that request and be able to modify it somewhat. Now what happens there is if it notices a container is about to start with a volume attached, it can reach out to PowerStrip plugins and say, hey, can you make me this volume please? and the plugin would be busy making that volume, send back to PowerStrip, I'm done now, and only then would the request hit the Docker daemon. We went to Docker with this, and we said, hey, look, you should really consider something like this, because companies like ourselves and Weave and Calico and all of these different companies need to interface with the Docker daemon in a way that's sensible. So in DockerCon in June, they announced plugins as under experimental tag, and we were very proud of that because, trust me, it took a lot of work to get that into the Docker mainline daemon, right? So there's now volume driver flag for Docker, and that is one way that you can use Flocka instead of manually, which I went over just now. You can say docker run --v, which I've said just before. It's like I want a volume that will persist over restarts. But if you then say --volume driver is Flocka, then Docker has nothing to do with the creation of that volume anymore. And much like PowerStrip, before the container starts, it's going to reach out to Flocka and say, hey, a container is about to start that will need a volume. Can you make that for me, please? But now, rather than like a man-in-the-middle hack, it's proper. It's actually in mainline 1.8 Docker. So if you download 1.8 and you install Flocka, you can literally use native Docker run commands and have clustered volumes in the way that we've just described. Moving on, let's go through some use cases. And the reason I mentioned the plugin is at the end we're going to do a demo with Mesos, and we're going to shoot a node in the head and it's going to reschedule, and that's using the Docker plugin. So I needed you to kind of know the context of how that works. This one here is, this node here is very, very busy, and this one's doing nothing. So you're like, you lazy bugger, you should be doing something more than you are. Let's reschedule, and using all these scheduling platforms, you can use constraints, and so I think all of the scheduling platforms have this idea of kind of saying, hey, I want this container actually to land here. As well as if you don't put a constraint, it will kind of use bin packing algorithms or random, or it will just decide which node to reschedule this container. So in this situation, we're like, hey, we want one of these guys to live over here, please, because then everything will be much better. And this happens. So that would happen on the scheduling platform, right? Kubernetes or Mesosphere will kick in, say, no worries, I'll move the container here. Without Flocka, this line, this white line here, I should use my tool, that's broken and you no longer have your data. With Flocka, it's going to attach the volume to the container when it notices that it's moved, right? So rebalancing your cluster to make things much more easier to, you're not seeing one server go through the roof and everything else is really quiet. It's definitely one use case. Draining a node. So, hey, I just want to get rid of this one, but oh no, there's stuff running on it. And again, it's a similar use case where you need to move both C1, C2 onto the second node, and Flocka will kick in and reattach the volume. There's another use case. And then you can get rid of this guy and everything's fine because the volumes have reattached. HA when a node fails. This is the demo we're going to do in a little bit, which is basically everything's happy, I'm running something, it's attached, and oh no, it blew up. What do I do? And in the old days, of course, it would be a pager goes off and you drive to the data center and you swear. And in this land, we're going, a scheduler, if it's any good, will go, oh, that's failed, but it had a container on it, so I need to kick in and do some work, which is to reschedule the container to the other node, and Flocka then kicks in and reattaches the volume. So you can see a pattern here is volumes are following containers around the cluster and treating them as a single unit, right? This is a really cool one. People ask me all the time, like, why would I use Flocka if I'm using a distributed database like Elasticsearch? And for a while there, I was like, that's a good point. Like, we don't try and claim and do everything, and we finally come up with a really good use case, which is, I'm going to use Elasticsearch as an example, right? If Elasticsearch node goes down, it's keeping copies of the data around the cluster. But if a node goes down, it needs to rebalance the copy of the data that it's just lost onto another server. Now that takes a lot of time in Elasticsearch land because it's at application level that it's moving all of that data. It takes a lot of CPU and a lot of network to move a large amount of data between nodes. With Flocka, and providing we're using network-attached block devices, we can maybe get to that in the questions later, what you can do is say, hey, let's kill this guy, and so that's the case where in Elasticsearch land, it would be going, oh, I've lost this as well, and so I'm going to take the copy from here and redistribute, and it takes a lot of time. In Flocka land, we can do this, which is, let's reschedule the container there, and the volume attaches immediately. And it turns out that's much faster than letting something like Elasticsearch do it natively. You're not trying to replace the features of Elasticsearch, you're just trying to give it a head start, right? It's trying to save time in recovery. This is this hourglass thing I talked about earlier. So we've got all of these guys up here. Should have put Cloud Foundry up there. Sorry, Colin, I always do this to you. There you go, next time. This is us in the middle. The schedulers are talking to Flocka either manually or via the Docker plugin. And here is this world of different backends that we support. And that is another part of what we're busily trying to do, is have a whole range of different backends. So, and that's a great abstraction now, because you're not having to think about the type of storage that you're implementing. And we're working with some well-known people I can't mention, but they have this code path where are we on EBS, in which case here is the volume provisioning code. Are we on our native Quobyte? This is the system that they use, which is like a distributed file system, software-defined storage system. Now, they have two entirely different code paths depending on which environment that they're running. And it's a mess, and they hate it, because every time they need to do something to volume provisioning, they're having to think about it in two different ways. Imagine if you had more than that, it becomes really difficult. And that's this sense of abstraction. So we're currently plugging in with this platform, and we're turning two code paths into one, where these guys just have to ask Flocka, can you please remount the volume? And they just need to change the dataset backend that Flocka is using. And rather than have two completely different sets of code to manage that difference, they're just having to change a configuration in Flocka, and that does the same difference, because we're hiding all that complexity away by busily plugging in different backends. So let me just go through a couple of these. Amazon and Google is on its way. EMC were our largest proponents at DockerCon. They even had our logo on their t-shirts. It was brilliant. So we had a really good working relationship with EMC. And we've got Scale.io and Extreme.io. So there's lots of corporate customers that use EMC hardware, and we're kind of looking at supporting lots of those use cases, as well as commonly used things like EBS. So the real point I'm making is that we're not opinionated about the storage solution that you should choose. It's up to you the best storage solution to choose. We're orchestrating that storage. We're not at this layer, we're in the middle layer. That's where I said earlier, we're kind of storage orchestrators, that's what we do. So that's the end of the slides, and I'm going to jump to the demo, which will take up the rest of the time, I'm sure. And just an overview of the demo is we're going to basically have a Mesos cluster of 3 nodes. One of them is the master, and there's 2 slaves. And we're going to run a stateful container on one node. And we're going to then shoot the node in the head, like to simulate that 3 o'clock in the morning, something's gone drastically wrong situation. Watch Marathon realize that that's happened, reschedule the container to another node, and watch Flocka kick in and reattach the EBS volume, and everything should be just as it was just now. So having talked it up, let's now see if this is going to be something that works. So let's have a look at... Right, so what we have here is basically our 3-node cluster. If I get out of the way, that might help. Can everyone see that okay? Should I make it bigger? Maybe I should get out of the way this way, that would be better. Right, so let's grab the Marathon GUI in our browser so we can see what Marathon thinks that it's doing. Okay, I think I already have it, do I? There we go. So has anybody used Marathon to any extent? A couple of people. So Marathon is basically a Mesos framework. Mesos is like making resource offers. A framework is accepting those offers and saying, hey, I'm going to run the thing I want to do on this node because it's got enough resources. There's like one sentence description of Mesos and Marathon. So let's have a look at the Mesos GUI, which I think is like an Angular bootstrap app. They could maybe spend some time on it, but it's fine, it works. Here's our 2 nodes, right? We've got 2 slaves in our cluster. We're ready to throw some stuff at that cluster. Let's close this, and let's just have a quick look at the EC2 console. These top 3 here are the 3 nodes that we're looking at, right? So we have the master and the 2 nodes. And what I've done as part of this whole thing is set up a load balancer. Because what that means is we're going to hit the same DNS record to see the app every time, even though it's just moved to another server. So just to make it much easier, otherwise we're like, oh, what IP address is now that? And it becomes not really a real use case, right? So let's first of all launch the application. Let's just remind myself of what it is we're going to do. So this is a good example here. And what we're basically doing is a curl command to here. So we're basically posting this JSON file to the Marathon endpoint that is responsible for starting applications across the cluster. So we're not thinking, what node am I going to run this thing on? We're just saying, hey boss, you work that out, I just want to tell you what I want, and I'm going to let you work out the details, such as where to run that thing, right? So what would be useful is to have a quick look at this app.json file. Have you done that, Matt? Yeah, right.
Yeah,
So it's that classic don't walk across a photo thing. So let's have a quick look at app.json, and right, this is the bit I want to show you, is Marathon just comes in a JSON manifest, right? So and it's fairly simple. You're saying, here's the container I want to run. You give it an ID. I'm not going to teach you everything about Marathon. Docker is Docker-specific stuff here. So we're saying the image that I'm going to run, the image of the container, it's bridge networking, it's going to expose a port so we can get to it. Here's the really cool thing. We're saying volume driver is Flocka, right? So there's the extra argument to Docker I talked about earlier with the plugin that says, don't just mount me a normal volume, mount me a Flocka volume. In this cluster, we're using the EBS backend, right? So that's how we can get away with HA. Even though the node just blew up, the data itself is across the network on an elastic block device. So when we run this, it will turn it, what Marathon does is take this manifest and turn it into a Docker run command. So you can actually hunt down in the logs the Docker run command that this will turn into, and it will be roughly along the lines of Docker run -v -v marathon demo :/data. Now, in a normal Docker run -v command, this would be a host path, i.e. it would start with a / somewhere on the host. If you notice, it's just a name of a volume. And that's the difference between a normal -v flag to a Docker run command and a volume driver -v command. With a volume driver, you're passing the name of the volume and allowing the driver to resolve what volume that actually means. And in this instance, Flocka's going to go, I'm going to create you a new EBS volume, mount it onto the host, and then return the actual host path where that volume is mounted. So once the container starts, it's pretty much the same as a standard Docker run command. It's just the plugin has had the chance to get involved before it starts, right? So let's do it and see the app. And then we can do the important part, which is to basically say, let's kill it. So if we make app, I think that's right. Okay, so it's uploading the Marathon manifest. I don't know why this bit happens, but I didn't bother to that part. Cannot resolve. I'm not even going to try and debug that. Let's see Marathon, right? So this is it going, hey, I've just received a request, and this is the important bar here. The yellow means it's currently doing something. So what's happening right now is it's choosing a node between one of the two slaves, and it's busy deploying the container. It's probably pulling the image right now, and so we're going to sit back, and maybe I could get the DNS of our actual, of the load balancer into the browser whilst that's busy doing that, and we can be amazed by the most important stateful web application in the world. So if you've seen it's just gone grey on the Marathon GUI, which means everything's good, it's running. I'm going to give the load balancer a couple of seconds to notice that it's running, because AWS load balancer does health checks to say, are you there? Let's see if that's going to work. Right, welcome to the most important app in the world. I'm going to do a big C for the contain thing. There you go. And this is the demo we did at DockerCon, actually. It went down a tree. It was the Gordon the Turtle secret session. So nobody had any idea what they were letting themselves in for. But this was our demo in a different context. We weren't on AWS and Marathon, but this is our kind of go-to demo for stateful stuff. So just to be very clear, this is one container. We've done this demo before where there's a stateless container speaking to a stateful database. I've made it really simple here so I don't have to get involved in networking containers together to not make the demo really complicated, but this version is just writing to a file, right? So let's just pretend it's the same as it's speaking to a database, just in one place. The key thing is there's state being written to the disk. And so each Docker click is just writing a coordinate to a JSON file on disk. Great. So the next thing is to kill one of the nodes, or we'll actually kill the node that app is running on. So I've made a lovely, I like this make thing, make failure. And so what it's doing is it's saying, hey, I need to know which node the thing is running on. It's determined that that's the node, and we've gone, hey, EC2, can you just terminate that node, please, right? So the whole thing is just gone away. Let's check that that's happening on the EC2 control panel. Which if we go here and we click refresh, I always think this control panel should use like WebSockets or something to save refresh. Right, there you go, shutting down. So it turned out that the app was running on Node 2, but I didn't really think about that, I didn't care. It's shutting down. So what's going to happen in not too many seconds is Marathon should, right, so you saw that just happen. Marathon said, something's wrong. And this is me still in bed, by the way. Although I'm clicking buttons, I had to actually tell it to fail. It would just fail if there was a real problem. We get that concept. So I'm sleeping. Marathon is busy saying, let's reschedule the thing onto another node. Now, there's going to be about 30 seconds or so where the EBS volume is unmounting, detaching, reattaching, and remounting, right? So I'm not sure there's much we can do about that timing. The main important thing that I'm making with this demo is that it's automated, not that it's immediate. So there's a small amount of downtime. As I say, I'm not sure how we can quite get around bringing it to 0 downtime. So in the next 20 seconds, I'm going to very quickly show you around the Marathon GUI. So let's click on the app that we launched, and how Mesos works is it turns applications into tasks. So you may well scale something up 5 times. So you have one application and 5 tasks. In this example, I've scaled it only once because it's a stateful container, right? So let's have a quick look at the details that it says. So again, it's saying staged, which is why it's still yellow. And this is the time I sit back and I go, the demo gods are going to work for me. So in the time that that's still happening, we're going to have a poke around the Mesos GUI. And you can see immediately Mesos is aware that there's a node that's gone, right? So now it's only got one choice about the scheduling decision it's going to make to reschedule. Imagine you have 100, though. That's a more realistic situation. So you're not going to even want to have to think about this. And I reckon, after having prevaricated, there you go. So now I'm going to give it a couple more seconds for the load balancer, which is busy doing health checks on both nodes to say, where is this thing? And I think that will give it enough time. And here we go. It's the moment of truth. Do we get something back? No. So I'm going to give it another couple of seconds for the load balancer. This is always that moment, isn't it? I'm fairly sure this will work though. I've done it a few times. There you go. It's back. Right. So and the next thing, this is the lovely conclusion. I'm still sleeping. I didn't even know that happened. I wake up in the morning. Somebody goes, do you know what? There's a major problem last night. One of our servers blew up. I'm just, okay. That's it. That's the end. So I want to say we are hiring, and that's the classic end to a thing. If you want to know more about Flocka, though, I mean, it's my job to know about it. So please don't kick me if you ask me a question that I don't know about. But I'm happy to talk about Flocka as the main idea. And so yes, any questions? Time for questions? Yes. Okay. Thanks. Perfect. Thank you.